My name is Patrick McFadin. I'm not only doing developer advocacy work, I'm also an Apache Cassandra committer. Yep, that Apache Cassandra, the one you use every single day. And that's actually what this talk is about. So I think this is the first thing I talked to maybe 4 or 5 people tonight already, and about 100% of you said this, right? Because this is the way it is, right? You're stressed out about not being like in tune. You're here because you want to learn something, right? And it's okay. This is a community of people that are in the same boat. Now, there might be a couple of us that are like ahead of the game, but we are learning together. And of course, if you feel like you're falling behind, ask. And so part of what I'm trying to say is we're all learning together. So let's try to make it easier on each other. Now, there are 3 things for success that I'm going to talk about tonight, but I like 3 things. 3 is a magic number. 3 is a magic number. So simple, private, secure, and performance for a low price. How about those 3 things to start with? Let's just do that for success. And I'm gonna demonstrate each one of these. And I said I was gonna do a high wire act and do some live stuff here. So let's do this. So let's start with simple. I don't know about you, but I've spent my life as a computer engineer doing complex stuff, and boy, the simple stuff sure is nice, right? And it seems like for my entire career, I've always tried to simplify things. Like, hey, well, let's build make files so we don't have to hand compile anything. Hey, let's use Java. That'll make it easier. No, it didn't. But then, hey, we'll use the cloud. Then you don't have to run your own computer. Oh, that sure is expensive. But then, hey, let's use AI and let us tell us everything, right? Well, we're going to figure out if that worked out or not. But I'm going to walk you through some real quick stuff here. So I work on Apache Cassandra, but I also work at DataStax. And part of what, if you've heard about Apache Cassandra, you know that, hey, this is a really interesting database, but I don't want to run that. I agree. I'll run it for you. So let me show you like really quickly. This is our Astra page, but I think this is something I'm proud of that we're working on. We're making Cassandra easy for everybody. So I'm just going to create a real database here. This is my very own. You can tell by the databases I have in here what I'm working on. And you're going to see one tonight that I have it running live right now. To create a database is pretty simple. And damn it, I wish I could delete this one, but I guess I'm going to have to, right? So this is what happens when simple happens. How many of you have deleted a database and not wanted to do it? Yeah. By accident, right? And I'm like sitting here going, oh yeah, this is going to be bad, but I'm just going to have to do it. Terminate database. And this is my favorite thing. Enter the database name, DB engines. Okay, so that's fine. Oh God. Bye. It's gone now. All right. So I guess I didn't need any of that data. But what's great is it's backed up. Oh, it's not gone yet. Hang on. So while it's terminating, one of the things that we've done is we've made it so all of these databases are very hands-off. You should only spend about 5 minutes of your life in this console, and that's to create a database. And what's happening behind the scenes is we're running Cassandra in Kubernetes. I wrote a book about that. But it's meant to be totally hands-off. The scaling is really simple. You don't have to worry about it. It scales to 0. You only pay for what you use. And that's important because, let's say, remember that cloud thing? Clouds can get expensive really quick. And what we don't want anyone to do, I've run Cassandra in production on a huge cloud. One of the things that happens often is that you wind up running a bunch of nodes that you don't need because you're trying to scale, right? You're all probably working at a startup and you think you're going to have the hottest thing since Instagram, right? Well, what happens at that point? You're going to need to scale. A lot of folks do these pre-scaling thing and then get way ahead of themselves. I'm going to come back to this in a second. But having scale, like being able to scale it up and scale to 0, means you don't pay for what you don't use. That's serverless, true serverless. So I have created a database, and I'm going to create one at the end after all these delete. So I created a database earlier called Astra Demo, and I'm running this demo right now, as a matter of fact, on my laptop. Just kind of prove it. Here it is. This is a demo that I have running. That what it's doing is it's right now, currently, it's doing a double indexer on Wikipedia. So it's grabbing Wikipedia articles, creating an embedding, and dropping it into Astra as a vector database in an Astra vector database. So it's just doing this right now on the Wi-Fi. So that's why whenever I go over here and look at this, it shows that I've already stored 300 some megabytes, almost 400 megabytes of data, but and it's pretty active right now. I've had this running since this afternoon, and it's already at 341,000. Ooh, who's going to pay for that? Probably me. All right, but connecting to it, it should be pretty simple, right? And that's what we want to make it easy for you. Whenever you want to use a vector database. So, and what's great is Frank's going to talk to you about why you would want to use a vector database in the 2 talks. There's Frank. He'll be over here in a minute. But he'll talk to you about some of the reasons you'd want to use one. I'm talking more about like the simplicity of using a vector database for your AI project. And connecting to it should be very easy and using the languages that you need. So for instance, Node.js, Python, Java, C++. Who's writing C++ code anymore? Oh, right on. Yeah, there's one. We got a driver for you. But I think what's more interesting is the API stuff. We have our JSON API, which is, I'm not saying it's MongoDB compatible because they keep changing it. So it's pretty close. But it's a JSON API. That means you can use TypeScript and that sort of thing. But most people are probably going to be using something like Python right now. And what we've done is we've built some really great libraries for you. We have one that's called Casio. And we work pretty extensively with Langsmith or the LangChain project and Llama Index, so that in that whole thing of simplicity, if you are writing a Python generative AI application, you don't have to do data modeling. You just put in the token and it will do all the data modeling for you. And what it does is it lets you do things like use LangChain for creating agents and that sort of thing. Llama Index, same thing, without actually having to think about the database. Because whenever you say you're chatting with your PDF or something like that, that should be like 3 or 4 lines of Python. And it makes it really easy to do. And that's what Casio does. And now what we're working pretty extensively on is LangChain.js and Llama Index TS, TypeScript, for the front-end applications. And if you are building front-end application, generative AI applications, that's probably what you're going to be using is JavaScript or TypeScript, because that's what you do. You use React or Vercel, Next.js, something like that. So the other thing that's really critical is this privacy and security. And it's funny because I always thought that was more of an enterprise topic, right? But generative AI has freaked everybody out, right? Because there's just so much it can do and get into your business, right? And let's say you're doing something with generative AI around healthcare or financial data, which is pretty. I know a lot of startups that are doing that. This seems to be very popular, healthcare especially. That's not data you want to mess around with because there are laws on that, and it's hard to be a startup like Instagram. I mentioned Instagram was easy. Take a picture, store it, share it with your friends. Great. Where's the security in that? It's literally sharing, right? And that's an easy, that was a great startup idea. But now with generative AI, the real magic is like what it can do for personal stuff for an individual. I have an example. Like I would like to say, hey, could you review all my bank transactions and tell me some interesting things? We have a bank that uses our vector database, and that's actually one of the things that they do is you can go into the banking app. This could be a good startup idea, by the way. You can go in the banking app and say, yeah, tell me how much I spent on fast food last month. Now, that's a pretty general thing to say, right? But it requires they access your personal banking information, and the LLM will take that natural language. All right, fast food last month. Okay, parse that out, and then go do a vector search on all of the financial data, your personal financial data. But it also returns back and says, "Oh, you ate too much McDonald's last month," right? Which I'm not saying that's me. Could be In-N-Out probably, but that is a good example of a really cool app that has zero chance of being insecure. I do not want someone to ask, like, "Oh, how much did you spend on PlayStation?" Because that's an embarrassing answer. So I don't want anyone to know that. But it's also like healthcare information is really tough. So this is something that we've really pushed hard in our world. When you spin up a vector database, we have this trust website, which is, these are like, it's so funny because I think of like, we've gone through this process of going through the ISO 27001. Like, who cares about that? A CISO. You know who you got to impress eventually is your CISO. But it's also like HIPAA requirements, PCI, SOC 2. All of those are what keep you from getting in trouble when you're working with other people's financial data or healthcare data. And it's become super relevant with generative AI applications. And we provide that. When you create a database, this is what comes with it. And if you need to have a HIPAA compliant application for your startup, there's just a few forms you sign and poof, your data is now HIPAA compliant. You can get government grants and all kinds of stuff because you're already there. That's hard. It took us years to get all these things. And that's something that we do and we're pretty proud of. All right, let's see where my databases are. Oh, all right. So now I'm gonna go back to the beginning. I'm gonna create a database. Let's see how simple this is. Thank God. I'm just gonna call it Jackson because this is his show. So I'm gonna create a new vector database. Oops. That's a bad interface. There we go. You can create like which region do you want to be in? And I'm going to use Google Cloud in this case. And boy, as simple as I thought it was going to be, but it takes a couple of minutes to start. Jackson, you have your own database. And right now it's spinning up my instance behind the scenes. But now what I can do is I can start getting into like things like, how do I want to connect to it? I can generate tokens for this. I want to be a database administrator, but we have a lot of, we have these really specific roles that you can create, again, for security and privacy, back to that. Like I only want a read-write service account, and that's it. Or I only want an API read and write user only. I don't want it to be able to manipulate anything. Well, generating the token. I mean, if we haven't seen one of these 1,000 times, right? Tokens are how we get the job done now. But that's what I use to connect to the database now. Really simple. And I can download those details if I want. I'm not going to. But in this case, I have a demo, this demo that I'm running here. This is a great demo. It's JavaScript, Java, and Python all in one app. So this is the demo that I was running over here is it's using Java Spring to load into the database. So you can see the server is all built in Gradle using Java and Spring. The embeddings are done by Python. And then the front end is all running with Node and React. So this is a full stack app with the only thing I'm missing is C++. Maybe you'd like to add that. PRs are accepted. Yeah. But I just give it the token for this particular app. This README shows like, I'll give the detail. I have the link for this that I'll give Jackson and he could share with you. But in the end, what you get is this thing it will be doing a lot of embeddings in a concurrent fashion. So let's go back to this. All right. So private and secure is one thing, but it's also this performance for a low price. And this is kind of wrapping things up, but you should not have to overpay for a database, and you should get the most performance for it. And that's generally not a cloud thing, right? Usually using cloud is not cheap unless you're using an S3 bucket or Glacier or something like that, right? Which is really cheap. But that's not very useful when you're writing an application. And I'm just going to click do this to avoid the issues with my screen. But since we're built on Apache Cassandra, this is a high scale database. This is a slide that Apple did. They have hundreds of petabytes of data running in Cassandra, and it runs across multiple regions around the world. And Apple does not do downtime. But the other thing is that we've built our database around the idea of concurrency. And that demo that I'm running right now is what's showing that. Concurrency is that you should be able to do reads and writes at the same time without it affecting the speed of your database. And so I like to pick on Pinecone. You're welcome, Frank. But Pinecone can't handle this. If you start doing writes to a Pinecone database, and your reads will start dropping like a rock. And why? Because it can't do concurrency. That's a hard problem to solve. And that is the performance that people run into all the time. And that's a big database problem. We solved this with Cassandra about 8 years ago, and it took us a few years to solve because it's a hard problem. So concurrency, the thing that we're doing right now, is really key when you're building an application and not just doing batch loading of vectors. You're actually writing an application. Users will be reading and writing at all times. And probably that's going to be, if you haven't heard this yet, you're probably going to be writing agents. It's not going to be a chatbot. Yeah, chatbots are cool for today. You should be doing chatbots right now. Next year, you're going to be writing agents. And those agents are going to be really creating a lot of load. And this is a great link. Yeah, I put the QR code for, this is Andre. Andre gave this great talk about agents at a meetup, kind of like this. The link has the full thing, but it's really cool because you think like, oh yeah, I get it. That would be cool. But the other thing is that's going to create an incredible amount of load on the system. All right. So you can do this today. You can use that link. That's my link if you want to log in. It's really simple. I got to wrap things up because we're almost over. I'm going to keep you on time. But you can use that link. We have a great startup program. So if you use your business email address, we have an intercom inside. Just let us know who you are. Once you get involved in this startup accelerator package, then we have lots of free credits, lots of free help. We want to help you get there faster. And we work with startups all the time. And it's the most exciting place right now in Gen AI is the startups, right? I think there's so many cool ideas and really interesting things happening in the startup space right here in San Francisco. This is why I spend a lot of time here. We should work together. I think it would be nice to go faster. And then one shameless plug, I'm the conference chair for a conference coming up in December. It's the AI Developer Conference and the Cassandra Summit. We're having two conferences in one. I have discount codes. If you want to connect with me on LinkedIn, I would love to hear from you. But it is, this is two conferences, and they're both being run by the Linux Foundation. So this is an independent event, but like I said, I'm the program chair for that. Right now we're working on keynotes, got some really cool confirmed keynotes from folks like Jerry Liu from the Llama Index is going to be there, I know for sure. Folks like that. And it's just going to be a lot of great content. We're expecting a lot of people, but it's at the San Jose Convention Center. Plenty of room for everybody. Just so we could show all the different code. It's because I don't know if you know this or not, but people get really particular about what language you use. So we just used them all. None at all. As a matter of fact, I don't recommend you do this in production. It's usually best to stick with one language or another. I mean, using Using Spring, for instance, with JavaScript and React is a pretty good combination. But mixing Python in there, I'm not sure why. But again, for demonstration purposes, it makes sense because then you can see all the different ways to do this. Yeah, this is not probably a typical. I don't know if anyone's running this in production. Tell me later. What's it gonna take? There's two things that I think are really critical. First of all, is having good agent frameworks so that that they are able to do the job that they need to do without failing. Agents should be able to run autonomously and without much intervention or interaction with humans. But GPT-4 is good. Llama, we have Llama 2. I mean, there's a lot of great LLMs out there, but they're not exactly sentient life. That's not AGI. How much, I think that's the question, how many agents are needed to get AGI? Now, hang on to your hats, everybody, because GPT-5 and Gemini are probably going to be released this year, early next year. And that's what everybody's a little freaked out about. I mean, everybody not in this room. Everyone looks calm here. But the world in general should be a little freaked out about this, right? Because GPT-5 is going to be a remarkable upgrade from GPT-4. And just the amount of research, look in the last year where LLMs have gone, just in open source. LLMs are teaching LLMs. If you look at Orca, for instance, Orca is a very small LLM that can almost match GPT 3.5. And so what's going to happen in 3 years, 5 years? That's amazing amount of time. But yeah, Gemini and GPT-5, along with the agent frameworks, is going to be, I don't want to say scary. I hope that it's actually really cool and useful. I hate to say the word Siri. Everyone's phone just freaked out. But I don't want Siri anymore. Siri's lame. It's like, it's so boring and it's great for timers. But I want to be able to tell Siri that thing like, hey, how much did I spend on fast food last month? I want to be able to converse. I want Jarvis. Everybody wants Jarvis, right? Thanks, Iron Man. You broke us all. But I think that's where we're going. And I think it's going to happen pretty soon. First thing it comes down to is you have to have a clear idea of what you're trying to accomplish with a clear path to how you're going to make that work. The technology is just the implementation. But what I could say is if you don't have a good balance between implementation and execution and good ideas, then you will never get anywhere. I hate the whole idea. I'm an idea guy, whatever. I could throw a rock and hit 10 people with ideas in San Francisco. And execution is great, but if you're not marrying it with the goal, like, I'm sorry, startups are supposed to make money, and I work for an open source project. I'm not supposed to make money. But startups make money. And so if you don't have an execution path that turns your idea into revenue through the implementation, then you're doomed. So good balance between those two things.